All right, you are welcome again. Today, let's talk about the proof of the properties of Cartesian products. We initially talked about basics of set theory, and under basics of set theory, we made mention of Cartesian product. And under Cartesian product, we listed some properties of Cartesian product. Now, in this video, we are going to take some of the properties and prove them. So the one we are going to take today says that we are to prove that A difference B cross C is equal to A cross C difference B cross C. Please, I want you to pay attention to this lesson, okay? Pay attention. It is very simple, and let's just get and know the logic. This is actually set and logic, okay? Now, before we continue, I want to remind you of some concepts. Now, when we talk about A difference B, what is it talking about? A difference B is talking about a set of elements, let's say X, such that X exists in A and the X is not in B. You get it? It's a set of elements such that X exists in A and X do not exist in B. Okay? Now, and also when we talk about A cross B, that is Cartesian product, we are talking about a set of elements, let's say in pairs A comma B, such that A, which is the small letter that denotes element, the first element, it comes from the first set. That is, we say that A comes from the set A, and then B, which is the second element, comes from the second set B. All right, we say that B comes from the set B. So this is the Cartesian product. Now let's go proper to the proof. Here the question says that we are to show that A difference B cross C is equal to A cross C difference B cross C. All right? Yes. Now let's go. When you have Cartesian product, it always comes in pairs. So because Cartesian product is involved in this question, so that is to say that the element or the nature of this element is in pairs. So we simply say, let the element come in pairs. And then let's say, let X comma Y be any element of the set A difference B cross C. We take the whole of the right hand side as a single set and the whole of the left hand side as a single set. So we say, let X comma Y be any element of the set A difference B cross C. You get it right? So that is to say that X comma Y exists in A difference B cross C. So if X comma Y exists in A difference B cross C, what does it mean? Now pay attention. It means that X exists in A difference B, or you simply say that X, which is the first element, comes from the first set. So we say that X comes from the first set. And what is the first set? A difference B. You get it? And then the second element, Y, comes from the second set, which is C. Then we say that and Y comes from C. Or you simply say that X exists in A difference B and Y exists in C. So in the first side, we said X exists in A difference B, the set A difference B. What does it mean? It implies that X exists in A and X does not exist in B. That is difference. You get it right? Okay, and then we have Y exists in C. Okay, yes. Now let's look at what we have in the right hand side. That is where we are going to. we have A cross C difference B cross C. So here we are going to bring A and B together. So if we bring A and B together, we're going to say that we have X exists in A and Y exists in C. You get it? You see it? And then we have X exists in B. You see it, right? So if we repeat C again, that is, if we repeat and say that and the Y exists in C, I think there is no any problem. Okay, for instance, if I say that your name is A and your name is A, is there any problem? No. Your name is A and your name is A and your name is A and your name is A. If I keep repeating and your name is A and your name is A, I think I'm still saying the same thing, right? Okay, that is the reason why repetition doesn't have any problem here, or will not give us any problem. Okay, now let's continue. So here we say that X exists in A and Y exists in C, and X do not exist in B and Y exists in C. Okay, so here this A and C, X exists in A and Y exists in C. If you want to bring this together, what are we going to say? We can simply say A cross C. Okay, is that true? Yes. And then that means we're going to have X comma Y exists in A cross C, where X exists in A and Y exists in C. Is that true? Yes. And then we go again, and X do not exist in B and Y exists in C. Now let's go again. In the beginning or in our destination, where are we going? We see that we have A cross C difference B cross C. You see this, right? Now look at this. We say that we have X comma Y. It exists in A cross C. We say that X comma Y exists in A cross C, and the X is not in B and the Y is in C. Now look at it. When we look at our destination, where we are going, we say that A cross C difference B cross C. And then here we have that X comma Y exists in A cross C, and the X is not in B and the Y is in C. So here now we can figure it out and say that X comma Y exists in A cross C, but it does not exist in B cross C. Hello. Yes, we say that X comma Y, we know that it exists in A cross C, but it does not exist in B cross C, because we can see that X is not in B, but Y is in C. So that is the reason why we say that X comma Y is not in B cross C. So we call it difference. So we simply put it this way. We say X comma Y exists in A cross C difference B cross C. So if we succeed in putting it this way, we conclude, we give our first conclusion. So our first conclusion is going to say that A difference B cross C is contained in A cross C difference B cross C. Is that true? Yes. Now let's go. We have succeeded in showing that what we have in the left hand side is contained in the right hand side. Okay, now let's go again and also show that what we have in the right hand side is also contained in what we have in the left hand side. Okay, so here let's also say that let X comma Y be any element in the set A cross C difference B cross C. So if we said X comma Y be any element in the set A cross C difference B cross C, that implies that X comma Y exists in A cross C difference B cross C. So if X comma Y exists in A cross C difference B cross C, what does it mean? We have difference. That is to say that X comma Y exists in A cross C and X comma Y do not exist in B cross C. That is difference. It exists in A cross C, difference B cross C. That is, it exists in A cross C but not in B cross C. Difference. Okay, now let's go. So if X comma Y exists in A cross C, what does it mean? That is to say that X exists in A and Y exists in C. You get it, right? Pay attention here. We say that X exists in A and Y exists in C. And then coming to the other side, we say that X comma Y do not exist in B cross C. But we have seen that definitely Y is in C. So that is to say, we are going to say that the only thing that is not there is that X is not in B, but Y is in C. X is not in B and Y is in C because it has been established that X is in A and Y is in C. So coming to this place now, we say that X is not in B and then Y is in C. Okay? Yes. Now let's go. Where are we going? Our destination, we have A difference B cross C. So we're going to bring A and B together. So if you bring A and B together, we're going to have X exists in A and X exists in B. You get it? X exists in A and X. If we bring A and B together, we say that X exists in A and X do not exist in B. Yes, that is what we have, A and B. X exists in A and X do not exist in B. And then we also have Y exists in C. So since we have Y exists in C 2 times, we can do away with 1. You get it? And then we simply say that Y exists in C. We know it. Okay? Now let's go. If X exists in A and X is not in B, what does it mean? It simply means A difference B. So we can simply say that X exists in A difference B and Y exists in C. So if X exists in A difference B and Y exists in C, what does it imply? We can apply Cartesian product here, where we say that X comma Y exists in A difference B cross C, where we say that X comes from the first set A difference B and Y comes from the second set C. Okay, so here we simply say that X comma Y exists in A difference B cross C. Okay, yes, we draw the second conclusion. The second conclusion is going to say that A cross C, that is where we started in this conversely, difference B cross C is contained in the final solution here. That is what we have in the left hand side. We say that it is contained in A difference B cross C. So here in the first conclusion, we say that A difference B cross C is contained in A cross C difference B cross C. And then second conclusion, we say that A cross C difference B cross C is also contained in A difference B cross C. And then in the law, we say that if A is a subset of B and B is a subset of A, where A and B are not proper subset, then A and B are equal. So here we say if A cross B difference B cross C is contained in A cross B, is contained in A difference B cross C, and A difference B cross C is contained in A cross C difference B cross C, then the conclusion, we simply conclude and say that A difference B cross C is equal to A cross C difference B cross C. All right? Yes. Thank you very much. Let's take another example. Stay blessed.